Hello everyone, welcome back to my another video. So we'll be discussing some questions of inorganic chemistry. So let's start with the first one. As per MOT, you have to state like how many statements are correct. So MOT plays a very important role in chemical bonding. And if I have to talk about the stability order of H2, H2 minus and H2 plus, then you know that key stability order is directly, or the stability is directly proportional to bond order, right? So if I talk about H2, then its bond order is 1. And if I talk about H2 minus and H2 plus, then its bond order is 0.5. So the relative stability, okay, would be like H2, that's fine, that it will be coming first, but H2 minus and H2 plus, that should be equal. So the first statement is wrong. Whereas for the second one, it's a pretty routine based stuff and it has been taught to you people many a times. He2 does not exist, but He2 plus and He2 minus exists. So the reason being for He2 not to exist is like its bond order is how much? 0. Whereas for the other cases like He2 plus and He2 minus, the bond order, since it is like 0.5, hence it will exist. Now also it is saying like the bond order of Be2 is not 0. So this statement is also wrong, because if I talk about Be2, then it will be like 8, and if it is 8, then it is like 4 electrons in BMO and 4 electrons in ABMO. Hence the bond order is how much? It is 0, but it is saying not 0, so this will be like wrong. Whereas in B2, B bond B is pi. Many students used to commit a mistake. They are saying like this is not pi, this will be sigma. But the thing is, it will be pi. The reason being it to be pi is the configuration of B2. If you talk about B2, then over here, instead of sigma 2 orbital to be filled first, you find that ki pi 2p orbital will be filling first. So that is very, very important. And if it will be like pi 2p orbital, there will have electrons. Hence, bonding will be mainly due to pi bond, not due to sigma. So this statement is correct. Whereas for the next one, like in C2, both bonds are pi according to MOT. So in C2, both bonds are pi according to MOT. That's pretty correct, because both the electrons, you will have it to be like in pi orbital only. So if both will be like in pi orbital only, then there will have two pi bonds which will be there, right? So this is also correct. Whereas for the sixth one, in N2, one bond is sigma and the other two bonds are pi, so that's pretty correct. There will have one sigma and one pi. Now bond order of F2 is 2. See, bond order of F2 is not 2, that's 1, you know. So this is incorrect. And it has been told again to that F2 only, ki if we are adding one electron, see, when you are adding F2 के अंदर one electron, it will become F2 minus. So if for F2 bond order is 1, then for F2 minus bond order reduces by 0.5. So it becomes 0.5 now. And if it becomes 0.5, then bond length, if I have to talk about, see, bond order is decreasing, so bond length should increase. But here it is saying it is decreasing. So its correct answer would be 4. Now for the second one, if I talk about calculate total number of colored compounds, this becomes relatively important from D block as well as from salt analysis. There's a mixture of both in this segment. See, if I talk about like FES, then the thing and all which is important is the oxidation state on Fe, that is +2. And if it is +2, then you know that it's a D6 configuration. So because of DD transition, we know that there will have color. And in D block, it has been taught to you guys like color and all will be mainly because of DD transition, or because of ligand to metal charge transfer spectra, or because of metal to ligand charge transfer spectra. So there are plenty of stuffs. If I talk about FeS2, that's iron pyrite, and over here also in this case you will be finding that there is a color. Whereas for this one, I think some 3 and all is missing. You know, it's a pretty popular compound that is called as Persian blue. So if it is Persian blue, then also it will have color. Whereas for the fourth one, in this case, you will find that zinc to be like +2. And if it's a +2, then it will be a D10 system, so it will not be having a color. Whereas for Fe3, FeCN whole 6 twice, this is like Turnbull's blue, so this will also be having a color. Whereas for the next one, Cu2I2, in this case, you will find that copper, That's a D10 system again. So there will not be having color. ZNS will not be having color, right? It's a D10 system. Whereas next one, this is very, very important, Ag2S2O3. Ag2S2O3 is silver thiosulfate and it is generally like colorless only. So if for Ag2S2O3, if you don't have this information, then it becomes tough for you to solve. Similarly, Ag2S is a black solid. And also in salt analysis, reactions of silver is very, very important. Next one is zinc hot. See, zinc hot is yellow in color. And this you might have been taught in solid state, like zinc, if it's hot, like it's yellow, and if it's cold, like it will be white. But anyways, it's hot given, so it will have color. Next one is CrO2Cl2, that's chromyl chloride. It's a red liquid, so that will also be having color. Next one is Cu2FeCN6. Again, यहाँ पे if you will be finding like there will have color. Another one is like Hg2CrO4. This is some sort of chromate, you can feel it, and this will have color. Whereas for the next one, KO3. See, if I talk about KO3, then KO3 is reddish in color. Okay, this is very, very important. And if KO3 is reddish, and on to the similar basis, if you are saying that K2 is also having color, then you will be wrong. See, it's an ionic compound and that's colorless. H2S, you know it to be like it's a colorless gas. Whereas for MNS, you know, it's a pretty important, compound with respect to its special type of color that is called as like buff color, which is nothing but dirty pink or pale pink, right? Now, question number third is from coordination, and that's over here. You can fill it out to be like NiF6, 2 minus. Over here, nickel is in like +4 oxidation state, and it's having very high Z effective. So in this case, even though you have fluoride ion as a ligand, but that will not be behaving as a that will not be behaving as a weak field ligand. In this case, because of very high Z effective, it will behave as a SFL. And if it is behaving as a SFL, so if you have a D6 system, then SFL, which means like what, all 6 electrons will be like into T2G only, EG will be free, hence it is not paramagnetic, so this is wrong. Whereas for NiCl2F2 minus cannot show geometrical isomerism, that's pretty correct, because if you can see the structure and all, you will finding like it will be tetrahedral. And also over here there is a concept of synergic bonding. One important lecture on synergic bonding I have taken some 10 days before, so you can go and refer it back, so this will be correct. And for the last one, stability of copper +3 is more than that of copper +2. See, we know that if you will have copper +3, then it will have D6 configuration, and if you have copper +2, then it will have D7 configuration. So you will finding like in D6 there will have high value of CFSC, which will cause more stability. So code 4 is also correct, and we need to know the sum, and also it's like 2 + 3 + 4, that equals 9. Now the fourth one, if I talk about first CH4 and CF4, electronegativity of central atom, you will be saying like both contains carbon only, so it will be same. Okay, so if this would be same, then this will be the order and all would be incorrect. See, this is a bit ambiguous, you can say, but over here I am giving positive marks to both the people who are saying that key over here carbon is what is having the same electronegativity. But if you can see, it's precisely like if you have CH4, you know that fluorine is very, very electronegative. So because of that, this carbon will be a more delta positive compared to the carbon that you have in methane. So from that perspective, if you see, and if you know that if any atom contains a positive charge, it will be more electronegative. So in that direction, if I move ahead, which ideally is the case over here, that you have to see it all the time, then A is correct, there is no issue. Whereas for the second one, like it's a ionic radii, if you talk about like Mg+2 and K+, it's an isoelectronic species. And over here also you will find like selenium will have more compared to sulfur, so this is also correct. Whereas for ionic mobility, we know that if ions like beryllium plus 2 is pretty smaller in size compared to Mg plus 2. So if it's pretty small in size, then you will find like hydration wala thing for beryllium plus 2 is like it will be more, so ionic mobility will be less. So the correct order for this one would have been the other way around, hence the C is wrong. So based on that, also electrical conductance if I talk about, then over here F minus, that's pretty small in size compared to Br minus, so this is also wrong because hydration in F minus would have been more. Whereas for the case of hydrated size, we know that hydrated size is like directly proportional to charge density. So in this case also the other order would have been the other way around, so this is also wrong. And reducing power, we know that it increases down the group. So if it increases down the group, then this ideally should not be, it has to be the other way around. So if I talk about like X to be like correct, then it has to be the first two statements, and Y to be incorrect, it has to be the other last four statements. So X minus Y the whole square, ideally it will be like 4. Now for the fifth one, it is based on structure, and I've told you guys like structure plays a very important role in P block. So if you have S2O2 minus, you must be knowing that the structure and all for that would be this one. And whereas for the second one, S2O3 minus 2, for that the structure is this. The third one, like you have S2O4 minus 2, so for that it becomes this as the structure. And the next one is like S2O5 2 minus, and this will become O minus S double bond O, S double bond O, double bond O, and O minus. Then S2O6 minus 2, and that one would be like S double bond O, double bond O, double bond O, double bond O, O minus and O minus. Then S2O7 minus 2, it's a routine stuff, right? S double bond O, double bond O, S double bond O, double bond O, O minus, O minus. And the last one is S2O8 minus 2, so this will be like O minus S double bond O. Basically there will have peroxyoxygen. So in this case, if I have to talk about the X where there is SS linkage or S double bond S linkage, then this X comes out to be like 5. Whereas the number of ions having SOS linkage, if I'm calling it as Y, and the number of ions having peroxy linkage to be like Z. So Y is 1 and Z is how much? The last one, the very last one, that is also 1. See, you need to figure it out like X by Y plus Z. So the right answer for this one would be like 2.5. Next one is from periodic table. See, you have oxygen and you have O minus 2. So basically what actually would have happened is like you have O oxygen, you will be giving 1 electron. See, it's an exothermic process. But the thing is O minus may again when you are putting 1 electron to make it as O minus 2, that is very very tough, and if it is very very tough, you need to supply energy. So it is not at all exothermic, right? You know that the second step is very very much tough, so you have to provide sufficient amount of energy. So this is incorrect, and incorrect is what you need to find, right? So over here this is fine. Now C plus 2 changes second ionization potential of carbon. No, there will have first ionization also that will be coming. So it's a combination of first plus second, not only second. So that is also incorrect. Now electron affinity of oxygen is higher than that of sulfur. It's a pretty routine based exceptional stuff you can say with respect to accepting the electrons. Oxygen being very small in size will have relatively lesser tendency to accept the electrons. So this is also wrong. And the last one is the electronegativity of sulfur is more than that of carbon. See, if you can see it, or on Pauling scale, you will find carbon electronegativity to be like 2.5 and sulfur is like 2.6. So it's like very much close, but yeah, there is a difference of 0.1. So this is correct. So right answer for this would be like A, B, C. Now the eighth one is from metallurgy, and it's a pretty routine based stuff. It will be like Agra, Bombay, and Delhi. Similarly, ninth one is also the same thing, and answer belongs to Agra, Bombay, and Delhi only. It's a pretty routine based stuff. And then hydrolysis of Noble gases, this is very very important. If you have to write the product and all, you must also be knowing the stoichiometric coefficients which are coming with respect to this. This is very very important. So this is the product, and if I talk about the stoichiometric coefficient, then it will be 6, 12, 4, 2, 24 and 3. Now the 11th one is again from metallurgy. You need to find the incorrect statement. So when you will go through the metallurgy of all important elements, you will be finding like B to be incorrect because all other statements are correct. Now the next one is like you need to find it out the correct bond angle order. So over here you have pH4 plus and you have CH4. In all these cases you will be finding like hybridization to be same. So if that would be the case, then it should not be like greater than. So that's wrong. Second one is like you have pH3, you have NH3. So over here you know that pH3 may there will have no hybridization, whereas for the case of NH3 there is lone pair, right? So anyways this will not be equal. If I talk about C part, then C part के अंदर you will be finding like you have NH3 and you have pH4 plus. So if it is like NH3, then it is like sp3, and it is like pH4, that's also like sp3 only, you can say. But in the case of NH3 there will have lone pairs, so because of valence chain electron pair repulsion theory it will be lesser. So C is correct, and D also you can easily be able to mark it out, right? Next one is like a treatment of HNO3 with P4O10. It's a very popular reaction where the compound and all which is formed is N2O5. N2O5, you know that it's a colorless solid, and solid N2O5 exists in the form of NO2 plus and NO3 minus, which basically is nitronium ion, and this one is like nitrate ion, and based on that you can judge it out and you will find that del A is correct. For the 15th one, there is a problem in the option. If I talk about the first one, there should not be having two double M, and for the last one there has to be like cobaltate. So rest of the things are fine, and you will sense it out that 2 and 3 are correct. Okay. Because if I will not be making that change, then all are correct because these two were same only. So I have to make it different. That's why I made this change. Now with respect to borax, it's a very important compound. You know that inside borax there will have BOB linkage. There will have OH minus. So you will find it out to be like there are 2 BO4 groups and 2 BO3 groups. Okay, so इसका right answer A है. And the last one is from hardness of water. That's pretty important. You know that hard water contains calcium plus 2, magnesium plus 2 ions. So at the time what happens is when they are reacting it with sodium stearate, okay, so PPT of calcium or magnesium stearate will be there. So if that is there, then because of that only Bombay is correct. So if I have to write the reaction like calcium plus 2 plus C17H35CO minus will be furnishing like C17H35CO whole twice ka PPT. So इसका right answer will be like Bombay. So I believe आपको मजा आया होगा session and all. We'll meet again in the next video with some different topic. Till then पढ़ाई करते रहिए. Take care. Bye bye.